Good day everyone, welcome to the Go Code Snippets channel. This channel is all about the Go programming language, and if you are new to this channel, please make sure you subscribe to the channel, and if you like this video after watching it, make sure you hit the like button and also share, and also hit the notification bell so when I release new videos you'll be the first to be notified. So today we'll be talking about pointers, and we'll also be talking about passing by value and passing by reference, and we'll see how that goes. So first of all, pointers in Go, just like how there are values of different types, each type in Go also has a pointer. So all pointers are just basically types that point to the memory address of a particular type. So if you are talking about pointer to an integer, it means a type that points to the memory address of a value of type int. So what I'm saying is, let's say we have a variable number and we print it to standard output. So if we want to get a pointer to this number, we'll just simply use the ampersand signal and the ampersand symbol. So to do that, we'll say number pointer. Also use ampersand, then num. So this gives us the memory address of where this particular variable num is stored in memory. So we'll also print that out. And see what we get. So let's run the code and see. So we have 5, which is our num, our variable num, and this, which is the memory address of where this 5 is stored. So this is actually called referencing. So this number point is actually a reference, or let's say, so it's actually called referencing the memory address of variable num in memory. So if we are working with a pointer, we actually want to get the particular variable back from the number and from the pointer. How do we go about that? So we just simply do something called dereferencing. And what dereferencing means is, just like as we converted a particular variable and we got the pointer, but if we are working with the pointer and want to get the variable back, we just dereference the pointer, and to do that we use the asterisk symbol, just like we use the ampersand symbol to convert to a pointer, then we use the asterisk symbol to convert back into a value. So we can just say num pointer dereference and just do it that way. Should be, so we use the asterisk symbol and we'll just say num pointer. So if you print this out, let's see what we get back. So run the code and see. So here we have it. So we have 5, which is our number. Then we reference the memory location using a pointer. Now we assign this to a variable num pointer. We printed that. Then we now dereference this variable num pointer back to get our number. So technically this and this are the same thing. So we can just check for the equality and see if we are right. So I can just print the num equals to num pointer dereference, and let's see if they are equal. let's see. So we get true. So referencing, you use the ampersand sign, and the referencing, you use the asterisk sign. So that's how pointers are. So now let's talk about passing by reference and passing by value. So in programming, there's a concept of passing by reference and passing by value. So passing by value is actually taking a copy of a particular variable and passing it as an argument into a function or a method. While passing by reference is actually taking a pointer to that particular variable, that means the memory address of that particular variable, and passing it into a function or a method as an argument. So the difference is in passing by value, since we are passing a copy, the original variable won't be changed, won't be modified. But in passing by reference, the original variable will be modified. So let us just see how that goes in code. So say I define a func foo that takes in an integer. So what func foo just simply does is just increment the integer by 2. So I'll just take this out. So I'll say, before that, let me just do something so we'll know we actually enter the function. So I'll do forms of println I am in foo. So let's do that. Or we should do foo called. Let's just do it that way. So here I'll define a variable num to be equals 10, for example. Then we'll do, so we'll print out 10, print out num rather, and see what we get. Then we'll call foo and pass in num into it. Then we'll print out num again. So let's see what happens. So here we are having num, so we printed num, so we're having 10. Then we called foo and we passed in num. So inside foo, num was actually incremented to 2, but because we're actually passing a copy of num into foo, not the actual value, because this alone means we're actually passing by a value. So what is happening is that num is actually incremented inside foo, but outside foo, num is still 10. It wouldn't change because it's a copy that we are passing, not the actual value. So the actual value, which is 10, won't be modified. So if we were to actually use this particular variable num inside foo, so it will have become 12. So anything after this point, it is 12. But outside this, anything after this point, so the variable I that we are passing is 12. And actually, anything after this point, variable I is 12, but that is as far as we're inside this function foo. Once we come out of this function foo and we come back into our function main, num becomes 10 back, because we're actually passing a copy of num into foo, not the actual copy, not the original value rather, so it wouldn't change. But let's say we are passing by reference. So to pass by reference, we'll be using a pointer. So to just change, so instead of passing a particular value, we're passing a pointer. So let me just say pointer to int. Then this one is going to take in a pointer to int. So when you put an asterisk symbol beside a particular type, that means you're actually calling the pointer to that type. So if it was a string, it will be pointer to string. Then it was a boolean type, string. Then it was a boolean type, it will be pointer to bool, and so on. So even if you're using your own custom defined type, maybe like a struct type, it will be asterisk and that particular type. That's how you call pointers. So in this foo, what we would do is foo called. I'm taking it out. Then what we just do is we just simply dereference pi, then we'll add 2 to it. So we dereference it, because when we dereference it, it becomes an integer. So we'll just add 2 to it. So like that. So we'll now call foo, then passing. So instead of passing in num, we're passing in ampersand num, because remember foo now calls a pointer to an integer type, not an integer type anymore, and the pointer to an integer type is actually what? ampersand value before that particular variable and the variable name. So if we do this now, here's what we get. So now we're having 12 now. So that's just how passing by value and passing by reference works. So in this case, what's actually happening is that we're actually referencing the memory location of num. So we are changing num in memory. So it won't be 10 anymore after foo is called. It becomes 12. So anywhere after this particular line, anywhere after this line, or in any other part of the code, so num becomes 10. No, num becomes 12, not 10, since we've added 2 to it inside foo. So that's how passing by value and passing by reference works. So you can actually also do this on our own custom defined type. So let's say I'm defining a type. So let me define a type and just say foo struct. So I'll just say it has a variable bar type int. So on this foo, I want to call a method. Let me just call a method on it. So let me say val of type int. So I'm calling. So if I call the method on a receiver of type foo, so if the receiver is just type foo, let's see what happens. So I'll be calling the method change val, or I'll be adding the method change val rather. I will take in an integer. So what change val will just simply do is just f dot val data. So f dot val should be equals capital F, not small f. F dot val should be equals to data. So let's see what this does. So here I'll just simply say, so I'll create a new variable. So let's say f should be equals to foo and the data is 10 of foo. So we'll call change val on foo. So f dot change val, then we'll pass in 12. So what we're just doing inside this change val method is just we're just assigning the value of the particular type, the value field. We're just changing it to the new data that we're passing in. So from here, I'll print. Let me print f dot val. Then I'm calling change val on it, and I'm calling f dot val again. Let's see what happens. F dot val. Then go on main.go. So here we're having 10. Then we call change val on this particular variable. So it's meant to actually change the value field to 12, but it is not changing because we're actually receiving by value. We're not receiving by reference. So to receive by reference, we just simply just put an ampersand or an asterisk rather to reference that it's a pointer that we're now receiving or not a value anymore. So I'm giving the pointer receiver this time instead of value receiver. So like this, let's now run the code and see what happens. So now we're having 12 instead of 10 because initially we're actually calling or we're receiving by value, but now we're receiving by reference. So that's what receiving by reference and receiving by value does. Even if I take out my asterisk sign, if I take out the asterisk symbol, and saw a particular error the other time. So I want to see what the error says. So the error says ineffective assignments to field foo.value. That means the linting GoLint is even telling me already that the data I'm actually passing, because as I'm trying to change the value of that particular type, like it is not actually going to work. It's going to be ineffective because I'm actually referencing by value, not by reference. So that's how passing by value and passing by reference actually works. So I'll just change it back to a pointer. So that will be it for this video. If once again, if you are new to the channel, please make sure you subscribe, and also if you like this video, like and also share.